Chapter 4, Atoms and Elements.
Mariah Lane,
Paris Dean,
Imani Rainey,
and Keith Carroll.
Alright, so elements and symbols. Elements are pure substances from which all things are built. They cannot be broken down into simpler substances. Chemical symbols are one or two letter abbreviations for the names of the elements, and only the first letter of the element symbol is capitalized, and all letters after are lowercase. For example, carbon chemical symbol is C, oxygen is O, cobalt is C with the lowercase o, and argon is A with the lowercase r. And here are some sample problems along with the answers. Alright, so Dmitry Mendeleev arranged 60 elements into groups with similar properties and placed them in order of increasing atomic masses. This is known as the periodic table. Each horizontal row on the table is considered a period. Each vertical column contains a group or a family of elements, and these elements have similar properties. The group number is written at the top of each vertical column. Group 1A to 8A are the representative elements. The block of elements in the center of the periodic table are known as the transition elements. Group 1A, which includes elements Li, Na, K, Rb, and Cs and Fr, are known as the alkali metals. And these elements are soft, shiny metals that are good conductors of heat and electricity and have low melting points. They also react vigorously with water, and they form white products when combined with oxygen. Hydrogen is not considered an alkali metal because it has different properties than the rest of the elements. Group 2A, which includes Be, Mg, Ca, Sr, Ba, and Ra, are alkaline earth metals. These are shiny metals like those in Group 1A, but they aren't as reactive as they are. Group 7A, which includes F, Cl, Bri, and At, are halogens. These are very reactive, especially fluorine and chlorine, and they form compounds with most elements. Group AA, which includes He, Ne, Ar, Kr, Xc, and Rn, are noble gases. They are unreactive, and they rarely found in combination with other elements. The heavy zigzag line that separates the elements, the metals and the nonmetals. So the metals are on the left and the nonmetals are on the right, except for hydrogen. Metals can be shaped into wires or hammered into sheets, and they are good conductors of electricity and heat. And some are Mg, Ca, Sr, Be, and Ba. Nonmetals are shiny, ductile, or malleable, and they are poor conductors of heat and electricity. And they are H, C, N, O, Cl, and S. The elements located on the heavy line are metalloids, except for aluminum, and they include B, Si, Ge, As, Sb, Te, Po, and At. Metalloids exhibit characteristics from both metals and nonmetals. So they are better conductors of heat and electricity than nonmetals, but not as good as metals. And they are also considered semiconductors because they can be modified to function as conductors or insulators. And here are some sample problems along with the answers.
Okay, my name is Paris Dean, and my part was atoms and their mass. So, an atom is a small particle of element that retains the characteristics of that element. So, Dalton's theory states that all matter is made up of tiny particles called atoms. All atoms are given elements are similar to one another and different from atoms of other elements. Atoms of two or more different elements combine to form compounds. A chemical reaction involves the arrangement, separation, or combination of atoms. Atoms are never created nor destroyed. The structure of an atom contains a proton which has a positive charge, a neutron which has no charge, and an electron which has a negative charge. The proton is positively charged particle, and they weigh more than an electron. An electron is negatively charged particle, and these particles are found within the nucleus. The atomic mass, the atomic number is the number of protons within the nucleus of an atom, and then the mass number of the sum of the number of protons and neutrons. So if you look here, you can find the atomic number and the atomic symbol, and then the atomic mass. So here's some questions with the answers. Some more questions with the answers.
Good day. I'll be talking about isotopes and atomic mass to start off. So for atoms and isotopes, beginning with isotopes, they are atoms of the same element that have the same atomic number but different numbers of neutrons. For example, magnesium, the atomic number will be 12, but because of that, it can also have the neutron can vary from either they stay at 12, 13, or go up to 14. And then we have our atomic symbol, which indicates the mass number in the upper left corner and the atomic number in the lower left cover. And you look to the right, you can see an example of different isotonic symbols for an isotope for magnesium. And then we have our atomic mass, which is the weight average mass of all naturally occurring isotopes for an element. To be able to find the atomic mass, you must be able to know the percentage, abundance, and the mass of each isotope, which must be determined experimentally. And then we have practice problems. And then we have the electron energy level, which is, then we have wavelengths versus frequency. When it's longer the wavelength of light, the lower the frequency. Then shorter the wavelength of light, the higher the frequency. And next is the electromagnetic spectrum and the electron arrangement. It shows arrangements of wavelength. First is the spectrum, which shows arrangements of wavelengths of electromagnetic radiation. A few examples would be radio waves, microwaves, ultraviolet waves, and for more you can just read here. Then the visible portion consists of wavelengths from 700 nanometers to 400 nanometers. Then we have with electron arrangements, that gives the numbers of electrons of an atom at each energy level. It's done by placing electrons at energy level beginning with the lowest. And to the right, you'll see a chart with some of the elements and the configurations. And then we have more questions.
Hi, I'm Mariah, and I'll be talking about the trends of the periodic properties. Electron arrangements are a very important factor for the physical and chemical properties of an element. In this section, we'll be talking about valence electrons, electron dot structure, atomic size, ionization energy, and metallic characteristics. Valence electrons are electrons that are on the outermost energy level of the atom. The chemical properties of elements are represented by groups 1A through 8A. Depending on which group the element is located in, will tell you how many valence electrons the element obtains. These electrons are involved in the chemical bonds with other elements. The electron dot structure, also known as the Lewis dot structure, provides a visual representation of the bonds between atoms and illustrates lone pairs of electrons in molecules. The valence electrons are illustrated by dots that may be placed on either side, either on the side, on the top, or on the bottom of the element symbol. An element cannot obtain more than 8 valence electrons in its outermost shell. When an element has 5 to 8 valence electrons, one or more of these will be paired. For an example, an element that is in group 6A will have 6 valence electrons. In order to label the element, you must figure out the symbol of the element first. Next is the atomic size. Atomic size is another physical property that characterizes the element's strength. The element's atomic size is determined by the distance of valence electrons from the nucleus when viewing the periodic table. The atomic size increases from the top to the bottom and decreases from the left to the right. This is true because the outermost electrons in each energy level are further away from the nucleus. For ionization of energy, the energy is needed to remove one or more electrons from the neutral atom to form a positively charged ion. Is a physical property that influences chemical behavior of an atom. The term of this process is called ionization energy. In an atom, negatively charged atoms are attracted by a positively charged of the proton in the nucleus. Therefore, a quantity of energy known as the ionization energy is required to remove one of the outermost electrons. When an electron is removed from the neutral atom, a positive atom called the cation with a +1 charge is formed. Ionization energy increases going across the periodic table, and it decreases going down the periodic table. Metallic character. Elements that have metallic character easily lose valence electrons. Metallic character is more common for metals, which are on the left portion of the periodic table. Elements that are non-metals that are located on the right side of the periodic table, they do not lose valence electrons easily, so this makes them less metallic. For metalloids that are between metals and non-metals, they tend to lose electrons, but not as easily as metals. The metallic character of an element decreases from left to right, and it increases from top to the bottom of the periodic table. And here are some questions that you can practice that go over the group number and placing the elements in order as far as the metallic character. Here are some interactive websites that our group came up with, and we viewed them and we found both the weaknesses and the strengths of all four. Thank you.